guys, welcome to another lecture from EcoPoint. So today we are diving into the concept of inverse functions. Whether you're tackling MCQs from CUET PG entrance or some math dominated ISI and IIT, this is a super important topic and mastering this will really boost your score. We'll cover the definition and step by step how to actually work out the questions related to inverse function. So let's get started. Let's define. So let's define inverse. We all know what a function is. I've already defined that for you, right? So y equals to fx. This is a special relation and under which we say that y is an image of x under the operator f, right? So y is a function of x. What is essentially happening is you have two sets A and B. You have some elements here, say x, and f is that map which takes x to some y which is equal to basically fx. All right. So what is happening is x is being mapped to y. In case I am able to map back this y to x, that means the inverse will exist. That means there is inverse. So what is inverse doing is that it is mapping back y to x. That is what inverse is doing. For example, suppose you have fx equals to 2x. All right. So this means that y is equal to 2x. Now I can say that it should be same as saying that x is equal to y by 2, right? Because what is happening is that I have this relation that if I have 4, 4 is equal to 2 into 2. So when x is 2, y is 4, or what can you say? You can say that x is nothing but half of y, right? So what you are doing here is what we're trying to say here is that 2 is being mapped to 4. And yes, I can map back 4 to 2 because that's a kind of relationship that you have here. But here's the catch. The catch is that for this sort of relationship, bijectiveness is important. The function needs to be one-to-one and onto. So your function must be bijective for the existence of inverse. If it's not bijective, for example, now bijective means it has to be one-to-one and onto. Now suppose I take the scenario of x square. Let's take fx equals to x square. Now I know that this function is many to one. It is a many to one. I'm not talking about onto right now. We know that this is a many to one function, right? Because I know that minus 2 and 2 both will give you, after squaring, 4. So what is happening is that minus 2 is also mapped to 4 and 2 is also mapped to 4, right? So if I try to look back from 4, can I map back 4? The problem what is happening here is that I can map 4 to minus 2 also and 2 as well, which will be a contradiction for the existence of a function. You can't map one element to two elements, right? That's the basic definition of a function. You need to have a unique image, right? So in this scenario, f inverse cannot exist. So for f inverse to exist, the scenario has to be, I'm just going to show you in terms of mapping the possibility of f inverse. So f is a function which is going from a to b. You have, say, x1, x2, x3 here. And for x1, say we have y1, y2, y3. So x1 is mapping to y1, x2 is mapping to y2, x3 is mapping to y3. All right. Now, suppose this is just one-to-one. And it's not onto. So let's take an additional element in your codomain. Let's take y4. Now y4 is not mapping back to anything. So do you think you will be able to map back the elements of B to A? No. So I need to have all the elements being mapped to something. And why do I need a one-to-one function? So this is onto. I need onto because I need everything in B to be mapped to A, elements of A. And I need unique image for it because F inverse that we are defining is also a function. So for it to satisfy the definition of function, I need a unique image. So therefore, that's the reason just one will also not help. It has to be one-to-one and onto. One-to-one is very essential, but onto is also important here. So when the function is bijective, you can talk about inverse, existence of inverse. Let's now talk about how to find inverse. So there are 2-3 simple steps. You have a function y equals to fx, right? You set the function y equals to fx. Now what you have to do is just solve x. Now what you have to do is you have to solve for x in terms of y. Just the way we do for our range. And what will happen? You will find that x is equal to something in terms of y. In case it's a scenario where the function is bijective, you will be able to actually generate that x is equal to f inverse y. So what essentially is happening is that x gives you y, which is equal to f of x, right? Now this y goes back and gives you f inverse y, which is nothing but this x. It's nothing but this x only, okay? In case it's an invertible function. So you get x in terms of f inverse y. You get x in terms of y. That is your inverse function. When in place of y, you put x, your functional form will become f inverse x. Basically, y is just, a variable to the formula. Let's understand it through some simple examples. So let's take the first very simple example so that all of you can understand the basic way of finding inverse function. So suppose you have y equals to 2x plus 3. Y equals to fx and fx is 2x plus 3. Okay. Now what you will do, you will set y equals to 2x plus 3. Get, this was step number 1. Step number 2, get x in terms of y. So it is y minus 3 upon 2 is equal to x. Now this essentially is f inverse y. This is f inverse function in terms of y. So you get to know that, okay, the functional form of inverse is y minus 3 upon 2. Now, if you are asked in terms of x, that find f inverse x, then all you have to do is you will just, in place of x, you will put, in place of y, you will put x. Because y is just a variable to this formula, that's it. Okay. So that means your inverse function is x minus 3 upon 2. If you observe, this was a very simple question wherein it is a one-to-one and onto function. So I really didn't have to check for anything. It's just 2x plus 3. So if it's an R to R function, you don't have any restriction. Your domain is R, your range is R, right? And there will not be any issue. Another way to check whether it's a valid inverse or not is to look at the composition f of f inverse at x. F of f inverse at x and also f inverse of f at x. So that would mean that you will check f of f inverse x, f inverse of fx. This should turn out to be just x. But of course, how will you do it? You will just put in the formula inside. So what you will do, f of f inverse x means that you are taking f of x minus 3 by 2. And here you are taking f inverse of fx is equal to 2x plus 3. So here, if you apply f on this, it will be twice of x minus 3 by 2 plus 3. Can you see? What you're getting is actually minus 3 plus 3 plus x. So minus 3 plus 3 cancels and you actually just get x, which means it is correct. It is the correct inverse. Similarly here, after substituting, after putting it the input 2x plus 3 in the inverse function, you will again get x. So this is absolutely correct. Now, let's take a difficult scenario. Let's take a typical ISI kind of a question. So next example. Suppose this time fx is x plus 1 upon x minus 1. I haven't provided anything to you, so your assumption is that f is from R to R. All right. Now, we want to find f inverse x and its domain. It's very important to understand the concept of domain and range when it comes to inverse function. And you'll understand now. Slowly and steadily, when you do more questions, you will understand that. Well, the first thing that I should check here is definitely bijective. So check whether this function is bijective. So is it 1-to-1? So for 1-to-1, this is a differentiable function. I'm going to take f dash x and it will give me. So for this, I should find out f dash x. This is a differentiable function. Let's just do that. So x minus 1 as it is. Derivative of x plus 1 is just 1 minus the derivative of x plus 1, which is the derivative of x minus 1, which is just 1, into x plus 1. Whole thing upon x minus 1 square, which is equal to, if you observe, what will happen is that x minus 1 minus x minus 1. X minus 1 square. So this cancels, and what you see is that this is strictly less than 0 for all x not equal to 1. And honestly, the domain actually is, domain of f is r minus 1, right? So for everything else, this is a strictly decreasing function. A strictly decreasing or strictly increasing function is a 1-to-1 function for sure. So that thing sorted. It is a 1-to-1 function. Now, is it onto? I'll talk about that later. But let's first of all, before actually onto, let's try to see what would be the inverse if it exists. So for that, what I'm going to do is I'm going to set y equals to fx and then find x equal to f inverse y and I'll get the functional form. So y equals to fx करेंगे, y equals to x plus 1 upon x minus 1. Cross multiply, this process is exactly like finding range. So cross multiply, you will get yx minus y minus x minus 1. I've taken everything to one side. This gives me y minus 1. If I take minus 1 common, I'll get, or I'll take everything to the other side. So 1 plus y minus 1 x. So x is equal to y plus 1 upon y minus 1. And this is what is your f inverse y. That means the inverse form. The inverse form is actually f inverse y. So inverse form is the variable plus 1 upon variable minus 1. So what you will see is that if I want to write it down in terms of x, f inverse x is nothing but x plus 1 upon x minus 1. Do you see that? You actually have the original function itself. The function is an inverse of itself. This function is an inverse of itself. And how can you define this? You can define this for y not equal to 1. So which means that you will be defining the inverse function also where the input is not equal to 1. So the inverse function also goes from, and in fact, if you observe from here, you can now talk about the range as well. The range actually has to be r minus 1 because what is your bad y? 1 is the bad y. So therefore, the inverse function that you define should be from r minus 1 to r minus 1. I'll just give you a mapping to understand this. Please understand something. When you have an inverse function, f goes from a to b. All right. Now you have x1, x2, x3. Now for the definition of a function, everything in A will be mapped somewhere. Now for inverse function, I require one-to-one function. Why do I require one-to-one function? I've already told you that so that I can map back. Otherwise, I won't be able to. Now suppose the entire B is not my range, but it's just a part of B which is the range. If just a part of B is the range, then this part is a very crucial part because what I can do is, if I am not able to create an inverse for the entire B, what I will do, I will create an inverse from this to this. So what I'm trying to tell you is that inverse function could be defined from the range of f, from the range of f to the domain of f. So always define your inverse function from the range of f to the domain of f. Even if you, in the function it's not given to you and you're assuming it's an R to R function, then also if you have a one-to-one function, you can easily generate an inverse function defining the domain and range of the inverse function carefully. All right. One last quick question. So let's take fx equals to x cube plus x. Is this a function for which we can find out inverse? Well, for that, what do you have to actually check? You have to check whether it's a bijective function or not. So what will you do? The first thing that you will do is you will find, it's a differentiable function, find f dash x. So you have 3x squared plus 1, which is always strictly greater than 0. So this means f is strictly increasing. If it's strictly increasing, that means it's a one-to-one function. If it's a one-to-one function, I can try figuring out the inverse. How will you do that here? Now, this is a very tricky one because if I try figuring out the inverse, what I'm going to do is I'm going to set y equals to fx, so which means y equals to x cubed plus x. Now, this is a cubic. What you essentially have is, if you see, you have x cubed plus x minus y equals to 0. This is your cubic equation. And the solution to this cubic equation, because what we require is x to be equal to f inverse y, right? The solution to this cubic equation is essentially your inverse function, which is a tricky thing to do, right? So how do we go about it? So in this particular question, the question which could be asked to you guys is whether the inverse exists or not. Because it's very difficult to explicitly find. Graphically, it's easy to actually see, but it's very difficult to find the inverse explicitly in this case. What you would be answering in this question is that it is strictly increasing. f is strictly increasing, of course, because of which this is a one-to-one function. And then you should also, for bijective, I also require the condition of onto. So we will check for the onto condition. How will we do that? F is strictly increasing, and fx is x cube plus x. So can you see, you should do the limit analysis here. When x is tending towards minus infinity, that would imply that fx is tending towards minus infinity. And when x is tending towards plus infinity, that would mean that fx is tending towards plus infinity. So therefore, the range of this function is R. Entire R can be generated, which means this is a one-to-one and onto function. So that means that we have a bijective function. F is bijective. Therefore, F inverse X exists. So sometimes some expressions are not that easy where you will be able to find the expression. But be sure that in case it's an MCQ asked in an entrance exam, either it would be a function where you will easily be able to, find out the inverse, or else the question would be molded in such a manner that you will be asked about whether it exists or not, like in this case. Thank you very much. I hope the concept of inverse would be very clear to you guys. I'll see you again in the next lecture now. Bye-bye.